hierarchical directories, which is a fancy way of saying you can have an you can basically have it flush through. So you can have a copy in memory, which gets committed periodically to disk, which in turn can get periodically committed to a database. It supports any number of hierarchical directories. So for clustering Lucene, clustering Compass, basically your choices are you either want to put it on a shared disk like a SAN, so that's typically the easiest option, or you want to go with a database. You can, as it obviously, because you can store your indexes in a JVC database. The issue there is that the latency is slightly is longer because it's never quite as quick as hitting local disk. But Compass 1.2 has an automatic in-memory cache, which basically addresses the latency issues with hitting a hidden JVC. So you can actually do it either way. The simplest option is just basically have a bit of SAN storage and put your indexes on it, because Lucene and therefore Compass supports concurrent access and write blocking and all the kind of usual.
If you store it on a hard disk, I presume you just point it to somewhere, some directory, and then it goes and create all the directories as filed under it.
Yeah.
But if you're storing it in a database, what is the schema for that database?
That's a good question. Unfortunately, I can't show you the example. Basically,
is it like a Lucene schema or a
schema? Or what it creates is it creates a table per subindex. So just as you have a directory per subindex, it creates a table per subindex called index. So it will create a table called index pet, which is basically then just this very large series of like key value blobs. It's like keys against blobs, and it will create one of those per setting. I guess any questions? If I've withered on too much.
Do you have maybe some example of how the search API looks like?
The search?
Search API.
Yeah. I'll show you. I'll show you what the search control looks like. So this is the provided control. Let's bring in this control which performs searches. And let's actually use this search. Basically, what to help with this, to help with the transactional behaviour, it provides the Compass API provides the template pattern. Like a Hibernate template, the Spring Hibernate template, for the kind of callback of like doing Hibernate. Well, you have the same thing with doing Compass. So you can have a callback to execute some stuff. I'll show you the Compass template plus. So basically, you can execute any query and perform like filtering and stuff like that, and within a transactional context, and then return from that the array of Compass hits. There's actually a Compass hits object. All the searches return as Compass hits object, which basically provides you with access to the detached hits. The distinction between attached and detached is to do with the lazy fetching from the Lucene index. Lucene, what makes Lucene so fast and has such low latency is because it's very good at lazy fetching. by default it only fetches the first 100 hits. So you might return a quarter, 250,000 results. You'll actually only return the first 100. You'll actually hydrate only the first, say, 100, which means that it can do it in milliseconds.
Actually, I was interested in a more specific question. If you have, assuming you have like 3 databases,
Yep.
2 sets of documents, and I don't know, some other set of data. Does it provide some API that you can just search for John and it will search across all the indexes, or you have to specify it manually?
Yeah, I mean, I suppose, the example here is a pet pony. We have 4 different types of data, and by default it will search all of them.
Yes, but it's one application, but just for objects, right?
Yeah.
I'm interested in somehow I have my enterprise business and I have several databases with different applications, but I'm interested in some searching and correlation between them.
Yeah, and I mean you could have a compass index. You could have a compass index spanning all of those different things because there's quite an interesting case where you can have one application actually feeding one application performing updates on another application. You could have a kind of one-to-many model.
Something like that.
Yeah, that would work very well. The only sort of caveat is that the way the compass currently works is that it assumes it has, when you do an index operation, it assumes it can kind of nuke all of the sub-indexes. It has control over all the sub-indexes.
Right.
But certainly Lucene itself supports federation of indexes and searching, parallel searching over the network, using RMI if you like, to distribute search operations. You can definitely search wildly different data. You could have you could have one compass index consisting of n sub-indexes of wildly different stuff. And the source of the updates could come from anywhere. And they could in fact be different applications. So you could have like 2 instances of compass, there are 2 entirely different applications pointing at the same shared disk. Obviously with synchronized mapping files, because otherwise the index will get screwy. They need to be mapped onto the same way. But because it can handle the write blocks correctly, you can have this one performing updates on part of the index while the other one's performing part of it. So you could scale that out and actually have it as a kind of enterprise search power. You might end up with some interesting kind of management issues around who gets to do how a full re-index will be performed. If it's 3 different applications doing it, but those kind of implementation designs.
Suppose if I wanted to search for, say, a person who is, say, 5'10", he's got a tattoo, and last known location, say, was Staines.
Yeah.
Now, if it is a national database, I'm only interested in this kind of person in this geographical zone. So, how does the underlying search engine give me my answer, basically?
Well, there are 2 things. Firstly, Lucene has two concepts as a query, which is the actual query itself, and then you have query filters, which can be applied on top of queries, and they're actually very efficient because they get cached. So you could have a query filter for location equals Staines, and that would narrow down the search space to Staines, and then you can apply any other queries, and they would all get filtered down to that.
Because in one case, Staines is like a filter to restrict the search. and the other case it might be input, not like a filter. You know what I mean?
Sorry, what?
For example, it could be like find all the people who visited stations.
Yeah, I mean, all of this works because I mean, Lucene, it's basically it's a set-based retrieval library. So, the set of all people who've been to stains, and the conjunction, it then either it does an or an and with the set of all people with tattoos, and then produce the matching results and rank them. So
do you provide these boxes in your search page, like a filter in your search?
Well, that's
only one box.
I mean, that's again a good point. Lucene by default provides a very powerful query parser, which supports syntax like basically Google style syntax of plus. You can do plus stains minus Lucene, which will find everyone, which will find all results that must have stains and must not have Lucene, or you can do plus stains tilde, which will find all words which are like stains, within a certain Levenstein distance of stains. Like, so it will find tains, I don't know, something like that, stain. So it will find the kind of similar words you can do, and you can bracket together. But you can basically do elaborate, Boolean conditions. You can do range queries where it's between A and B. You can do not in. Any kind of conditional logic you can imagine, you can pretty much put together. So Lucene provides this query parser, and so you typically with any user input queries, you'd run through that, or you could construct them programmatically. So either's good.
Can I just ask a question about mapping? I'm
Yeah.
confusing myself what the use of the word is.
Mm-hmm.
Is it mapping a field in the Lucene database to an object, or is it mapping? Does it mean mapping as in terms of a collection of words, like a map, or
No, it's pretty much it's the form. So it's like, think of it. If you use Hibernate, think of it. Right, okay. Well, it's like so it's saying I want to index first name, or I want to index address, and I want to map that to a field name customer underscore address. And so that means my index will contain a field called customer underscore address, which whenever I get a customer object will contain, will be marshaled to it in front, and whenever I get a search result, it will be marshaled front.
Yeah, I understand that. So, what I was thinking of was if you could, is it possible to make, I'm not sure if it's Compass or Lucene that would do the job, but if you can get some kind of recognition so if you've got a collection of web pages and you somehow stuff them in a database, and you want to try and recognise, you've got maybe 100 search terms, common, if you've got a, something that commonly occurs in certain subjects,
absolutely.
like
That's
football or Java or something, then you can compare your template to that, say, okay, probabilities that this is going to be
absolutely
about that. So can I say this is more probable or less probable, or
absolutely, because
that's
the important part. What it does is keep term frequencies. It's a term vector. So it says, if I fire up Luke again, because that gives a nice illustration of how it works. Yeah, I mean, this. So if we look here, we have So this shows a frequency distribution of all the terms. So if you, for example, one term, if like a word, if we'd index like natural language and we'd included words like and, you'd see like a small curve and then shoot right at the end where all the ands kick in and show the frequency. But yeah, I mean, if we go back to here, we have the top ranking terms. So here, if I can pick like first name, show the top terms, and then you can see that actually there's only one record here for each one. But we know, if you run it over a substantial data volume, like I run it over for my 1.4 million names. I think I had like 60,000 Michaels. Michael, John, David. And you could see the distribution of the top 50 names. So yes, and then using low-level Lucene APIs, you can do stuff like DigiMe, because you can from those top terms you can build a dictionary and go, well, your search term of T-set is quite like a very popular word, test. Did you mean test? Which is what Google does. You can't do it out of the box with Compass at the moment, but it's definitely possible.
You said you can map Java objects to resources like JDBC, connection, and XML. So if you have a database in which we are putting in, say, Word document, we can't do a search for certain words inside a Word document in a database. That's a good point. What you need for this is content extractors. For example, what I have in several applications is users upload attachments, and we have an attachment domain model, an attachment class which has attachment ID, file name, a byte array which is the content of the attachment, and some dates and whatever. What you can do is you can you can have a content extractor set up and mapped in Compass. So for example, if in my attachment class I can say use the binary content extractor for the content member, which is a byte array, and then you can run it through like something like POI to do or PDF box to extract the text from the binary content and then just index that. So yes, it's eminently possible, but you need to plug in some content handlers. Right. Thanks.
Is there some monitoring or management API provided on the top of the campus? Like, for example, you want to know what do your users search typically? What are the top searches that they do? Or for example, when the last indexing was performed?
Google don't want to disclose that.
Yeah.
No, out of the box, there's not really, but it's really easy to have that kind of stuff because you can do it using an interceptor, or you can just have I think again you can have register lifecycle listeners. So no, I mean it doesn't provide like a JNX bean or anything like that out of the box, which would be nice, but it would be fairly easy. You could always submit it as a patch.
The results page.
Yeah.
It gives you 4 or 5 lines of text. I presume it is up to the software developer.
Yeah.
If you select an item, it takes you to some meaningful content.
Yeah. You need to decide what's meaningful from an application perspective for those results.
For example, suppose it was a parrot or something like that, which is a green parrot. So, do you actually expose your primary key?
Well, you'll have the object. So if we go back to we have hit.data, which is the object. So if it was a pet object, you can then just do hit. Whatever fields are available on pet, like pet ID, pet name, pet color. You can then just display those or do whatever you want with those.
If they were indexed.
If they're indexed, of course.
I noticed that in the mapping, it was mapping the ID. So the actual primary key is going into that index.
Yeah.
So that.
Yeah, I mean, you do typically want to use the primary key. I mean, you don't have to, but it'd be fairly meaningless if you didn't.
No, but sometimes we don't expose in an HTML page the primary key of the underlying database.
I mean, there
We
would
create
be
a layer of abstraction between what
Yeah.
is displayed and actual key. So if it's like number 1 in the list, we know what the key is when the item comes back.
Yeah, I mean, it's really whatever you want to do with it, because what you get back is your Java module. So, what you do with it is really up to you. Whatever's meaningful for your application. You can output a link with the primary key. You can output nothing. You can output a picture. Really doesn't matter. Whatever meaning.
So could you use, Lewis, a surrogate key for that?
Yeah, I mean, anything you can calculate from calling a method on your class or using a utility method, really, it's all code. So it's and yes, of course, like my hibernating and stuff, you don't have to use a primitive as your ID. You can have some kind of ID class that calculates the ID value based on a composite key or whatever. Interestingly, you can actually use I haven't mentioned this, but you can use really dynamic data. You can have value of things being calculated by velocity. So you can actually, I think it also supports Jelly and various other scripting languages. So you can actually do some really interesting runtime manipulation of data with it.
Yeah. All right. I think we've got about a couple of minutes for more questions. All right. I will just ask. Compass and Lucene. I know Lucene does incremental indexing on the fly, so Compass actually builds on that.
Yeah, absolutely. I mean, so. Yes.
The last thing I did with Lucene was searching on an email form which was stored in a database. So I imagine it's very useful that you could work with financial data or equity trade data. And one of the things, 2 things I did before it was called scheduler, I did a synchronization of the index as a long-running thread process, which is very useful if you're going to give customers some data. You just tell them to push this GUI button and it indexes. And the other thing is also the incremental indexing. So that also works. So that's very exciting, and that Compass can do something like that.
It's very cool. It's good stuff.
So I imagine you could use that with investment banks in financial services, which has terabytes of data.
Yeah, I mean, absolutely. I mean, the main concern with scaling out the data is just if you have to do the full index, it's going to take a while.
Yes, if you have to go live and you haven't done any indexing of bond trades, and then you've got the old Java problems of you can't say select star from the bond trade database and get a bazillion records. So you need some.
Yeah, no, I mean, this is where the GPS devices deal with this relatively gracefully because they use scroll result sets and stuff.
Okay.
So on the iBetas one, I've submitted a patch so that it does it row by row, so it doesn't actually try and load a million rows.
Right.
But obviously there will be a memory impact because you need to at least hold part of the indexing memories whilst it sorts it.
So if you wanted to do that, you said you can do that periodically. So you can start a thread and say, right, this is a long running process. I've got a billion to do. I'm going to do the first million and then shut down. and let other clients do their work.
Absolutely.
Well,
You can have a custom indexing strategy like that. It's fine. And you basically run it under like a patch, because the transaction isolation, you can have a normal one, or you can have a batch transaction isolation, which only supports inserts, and will just will bulk them up and make them very quick. But yeah, I mean, indexing performance is actually quite good. So doing 1.3 million names and addresses takes around 40 minutes, a single thread.
so you can do something like overnight.
Yeah.
And what about Ajax? If someone wants to do a kind of suggest thing.
Oh, this is I haven't really mentioned this, but this is one thing I've been using this heavily for because it works really well because the latency is very low. I mean, you can turn around the search results in under a second. So in all my current applications, I have like employee name, when you find looking up clients or employee names, start typing and using Scriptaculous as Ajax autocompleter. Just actually with a back end, which is just the standard Compass search controller and a very minimal JSP page, which is just a URL with a bunch of items on it. Return works beautifully, and it's fast enough that it almost keeps up with your typing. So I really recommend that. So
you process the compass hits, let's say the first 10 compass hits, and just return.
You just return the first. You set the page size to be something small, like 10, 20, because obviously with an autocomplete you want to fit it on the screen. So you say 20, and then at the bottom, because you always know the total number of hits, you just say 350,000 more, and then they keep typing. It goes down to 250,000 more, 20,000 more, 1,000 more, no more hits. It works very well, I really encourage people to do it because you can do stuff like you can do prefix searches, so you can start doing. If you're searching Michael Gray, you can start doing MI space GR, and it will find Michael Gray and Michael Gradsky. It will get all of your matches, and then so it also doesn't really care if you type surname, first name, your first name, surname. It will just go, and absolutely. Another more radical option is you could theoretically use it for all of your front end data access operations. Like showing lists of trades or showing lists of orders. I don't know whether the performance your mileage may vary because the query use case is there. Because it's very good for some things, but databases are general purpose things and they're quite good for most things.
Yeah, I mentioned some. So you have performance versus scalability issues, and normally I would imagine you'll be using some kind of second level cache.
Yeah.
So you can do intelligent things where you start typing 2, and that means like a sell price, but then you might recognize a search time by 2. The user type 00 and then 7. Oh right, I've got the beginning of the day.
Yeah.
And then you brings out a whole set of different objects. So it can be quite clever. Whenever you start searching books, like someone types ISBN, oh right, it's make it
so exactly. That's exactly the kind of this is the kind of thing you can implement. I think more than anything, Spotlight illustrates why this is a good idea because it's a great execution of a powerful idea.
In the mapping, you define like what you're going to search on. Is that right? The mapping defines what you're going to first name, last name, whatever.
Yeah.
Right? And then you do this indexing thing, which is time consuming, but you only do it once.
Yeah.
And then it just takes its own life cycle. But now suppose in the future some business fellow says, I want to search on these 5, 6 things. Now the mapping was done by annotation.
You can either do it by annotations or XML.
It require redeploying of the application.
Yes, yeah. If you update, if you update the mappings, you will have to redeploy your application, and that's to be it.
That's
But it's actually quite the index structure is actually quite forgiving, because if you update your mappings and you haven't updated the index, it won't actually mind. It won't the application won't just crash out because you can't find the particular field. It will probably cause some weirdness, but yeah, you can redeploy your application and re-index, and you're all good.
And you have to re-index.
You don't have. Well, it really depends on the nature of the change you made. If you've removed fields, you don't have to re-index. If you've added them, you don't have to re-index, but you won't get any format, you won't get any data.
If you were indexing against a database, so you would probably have intervals, so every 10 minutes, for instance. If you start, say, 10 o'clock, your next index, is there a danger of missing a record, perhaps, if a record was inserted during your during the indexing? Because you would probably start, if it's every 10 minutes, 10 o'clock, the next indexing would be 10:10. Is there a danger of losing a record at all?
That really depends on how you structure the query. If you're doing that case of doing like querying to find updated records, obviously there are a lot of ways around that. I mean, actually, another important thing to mention is that Compass, when it's doing an index, it creates a copy of it builds over a copy of the index. So you saw there was a folder called index. What it does is when it kicks off a new full re-index, it creates another folder called GPS index, which is what the GPS devices are feeding all their data into. Then, only when they've completed successfully, it will delete and rename the GPS index to the index one. So if your full re-index fails halfway through, because it runs out of memory or database connection fails or whatever, then your old index remains untouched. So, quite nice.
One last question.
Right, this is the final question.
That's when you get that, so you have an existing application, and then the requirement is let's put a nice elaborate search on it.
Yeah.
So then we put the annotations for the mappings, etc. Redeploy the application.
Yeah.
And we've put mappings on resources. So anything that's new gets indexed.
Okay.
But what about, how do you go about searching on old data that's already in the database?
Indexing. You need to have a GPS device to index it. So the bare minimum case is you have, because in map, how would you get, if you have your classes mapped, so say for example you've got 2 million customers,
Yes.
how would you get 2 million customers? Because you must have some way of mapping, you must have some way of retrieving those customers. So you basically do that, you call that method, returns all your customers, and then just throw all those customers, just say, you could just say, here you go, here Compass is a collection of customers, or where you go. Obviously, you wouldn't, that would be a naive approach because you can never fit them all in memory, but the basic idea is that you can call a business method to get a bunch of stuff and throw that into Compass.
And that's how it index the old data.
Yeah.
All right, thank you very much, Lewis from Lehman Brothers. A wonderful presentation. It's very interesting to hear about OpenSymphony and Apache.
Thanks.
Yes. Thank you very much.
Thanks.
I have a couple of books to give away. So the first question is, what is the concept that Compass automatically uses to index all keywords? What is the concept that Compass automatically uses to index all keywords?
Is that virtual field?
That's the answer, virtual fields. Easy one. What does the acronym OSGI stand for? OSGI. It's a big clue because that's the next birds of a feather on the 4th of December. So I'm getting my plug in. Good guess?
Can you search for that? That's a quick
Open Symphony, Google Box, or something.
Open source something initiative. I don't remember what is JAVA.
Okay, what's the? I have to put up a different question.
There we go.
How about if I make an addition to an information, the Luke thing you've got, that's a Swing application, is it? Java application? There's also a web-based, similar sort of thing, which is called Limo, if you've come across that. So that's an interesting...
Not to do with Google, is it?
Nothing to do with Google. Okay. No idea yet?
Ask me my name, please. I'll give you.
Yeah.
Provider.
No. Yeah, provider.
That's the object of the XML file, and that's tricky for 3 or 4.
Okay. What is? You want to ask a question about your presentation? I'll keep the book away.
So yeah, I mean, what things can we index?
Text. Text.
Yeah. It's all text.
I wasn't paying attention.
There you go. Well done.
Cheers. Thanks.
And last concluded Bob 31. I see you're down at the pub. And OSGI stands for Open Systems Gateway Interface Initiative. Oh, Open Services Gateway Initiative. And that's all about modularization, Java, which is the foundation of Eclipse. Plugins. Thank you very much, Lewis.